All right, so OpenAI's new GPT-o1 models. Everyone's talking about them, right? This whole reasoning thing, it's got people fired up. We're going way past AI just spitting out lines of code.
Yeah, this is different. These new models, they're supposed to actually think through problems, like almost like a human would.
So to see if they're the real deal, we dug into some experiments this developer did, really put them through their paces.
Yeah, he wanted to see how these models, GPT-o1 Mini and GPT-o1-preview, stacked up against the big dogs like Claude 3.5 and even GPT-4, and not just like trivia questions or anything. We're talking real-world coding challenges.
Yeah, building stuff. And lucky for us, he documented the whole thing on YouTube. Two challenges really caught our eye. First up, building a space game, like a full-on functional game.
The whole shebang, JavaScript, sprites, those little graphics, collision detection, all of it. We were really curious to see how these GPT-o1 models, with all the hype around their reasoning tokens, would handle this kind of creative task.
Okay, gotta ask. Reasoning tokens. Sounds kind of sci-fi, doesn't it?
Yeah.
Break it down for us. What are those and how do they actually work?
So imagine the AI is like having a conversation with itself. It breaks down the problem step by step. Instead of just spitting out a chunk of code, it uses these tokens to try different things, explore different approaches, almost like a mental flow chart. The developer actually shows diagrams in the video, and it's actually kind of mind-blowing to see this internal dialogue happening.
Hold on. So the AI is like thinking out loud, trying to figure out how to build this game. That's wild. But is this just theoretical? Can developers actually use these models right now?
That's the cool part. The developer, he set all this up in Cursor. It's a code-generating IDE that a lot of developers are already using. So yeah, this isn't some like far-off future tech. It's here, and you can try it out yourself.
No gatekeeping here. Okay, so how'd they do? Did these models manage to, blast off with this space game challenge?
Well, Claude 3.5 came out swinging. Honestly, I was pretty impressed. It actually managed to create a fully functional game on the first try.
First try. Get out of here.
I know, right? Sure, there were a couple of minor bugs, but I mean, let's be real. Even human programmers, we don't get it perfect on the first go every time, right?
That's true. That's true. So are we saying AI is getting good enough to like outperform humans at some of this coding stuff?
It's definitely giving us something to think about. Now, GPT-o1 Mini that's a different story. It really struggled. The code was buggy, the gameplay was glitchy. It just couldn't quite stick the landing,
So, sounds like a bit of a crash and burn for the mini model.
Well, not so fast. And this is where things get interesting. While Mini struggled with the actual game creation, it excelled at something else: debugging. It gave super detailed code explanations, tracked changes like a hawk, and even offered potential solutions for the bugs it found.
So like having a superpowered coding buddy looking over your shoulder.
Exactly. And that really makes you wonder, could these reasoning models be incredibly powerful debugging assistants? Even if they aren't the primary creators, it's definitely something to keep an eye on as this technology develops.
Okay, so Mini surprised us with its debugging skills. What about its bigger, supposedly more powerful sibling, GPT-o1-preview? How'd it do?
Well, if Claude 3.5 was quick off the mark, GPT-o1-preview took its sweet time. It needed a lot longer to generate the code, and even when it finally did, the results were mixed.
Not an instant win then?
Not quite. The code was definitely more complex than Claude's, but it still needed a good amount of debugging. And the final product, even though it was playable, it lacked the polish and even some key features that Claude's version had.
So too much hype, maybe, at least for now. Or do you think these reasoning models, they're just not built for this kind of real-time creative coding?
It's important to remember we're still in the early stages here. These models are under development. The space game thing, maybe that's not their jam, but they might really shine in different areas. Speaking of, the next challenge throws them into the world of finance. Building a Bitcoin trading simulation.
Ooh, okay, now that's what I'm talking about. That sounds like a real test. Let's see how they handle the wild world of crypto. Okay, so from spaceships to Bitcoin, what'd they have to build this time?
This one was interesting. They had to build two systems that work together.
Two? Okay, so it's getting more complicated.
Yeah, one system had to fetch historical Bitcoin price data, like what the price was over the past couple of months. Then the second system would connect to that first one, grab the data, and then, get this, design different trading strategies to see which one worked best.
Wait, hold up. The AI is actually making decisions based on the data. This isn't just like, fetch this, do that.
No, we're talking like analyzing data, understanding trends. It had to make judgment calls.
Did he throw in any curveballs? Like, make it use all that Wall Street lingo.
Oh, for sure. We're talking moving averages, Bollinger Bands, the relative strength index, the whole 9 yards. This was financial modeling, not just basic coding.
Okay, now I'm really curious. Claude 3.5 kind of killed it with that space game. Did it keep up its winning streak with this Bitcoin challenge?
Claude 3.5, once again, delivered, clean code, well documented. It even suggested using Docker, which is like this tool to make implementing stuff easier. And get this, it created a working simulation with 3 different trading strategies built in.
3. Dan, okay, were they just basic ones, or did it get fancy?
It covered a good range. You had your basic buy and hold strategy, then a simple moving average crossover strategy, and then it even threw in a strategy based on Bollinger Bands.
So, like, the AI was actually thinking about risk and all that.
Yeah, and it wasn't just throwing random code out there. It explained each strategy, how it worked, the pros and cons, the whole shebang.
Okay, I'm impressed. So Claude's on a roll. How'd GPT-o1-preview handle all that?
So this is where you really start to see the difference in processing speed. Remember how GPT-o1-preview was slower with the space game?
Yeah, it took its time.
It was even more noticeable here. Claude was pretty much instant, but GPT-o1-preview took over a minute per response.
Wow, okay, that's a pretty big difference, especially if you're, like, trying to experiment or test different things quickly. But did it at least manage to create a working simulation with those complex trading strategies?
Well, here's the thing. GPT-o1-preview's code was way more complex than Claude's,
No.
but it didn't suggest Docker. And out of the 3 trading strategies it came up with, only one, the buy and hold one, actually worked correctly. The other 2 had errors that prevented them from running.
So it's like it was going for the gold, but it tripped on the way there, tried to get too fancy and stumbled a bit.
Exactly. And it just goes to show, with AI and coding, more complex doesn't always mean better. Sometimes a simpler solution, like the one Claude came up with, is better, especially when you need something reliable.
Yeah, it's like you can have all the fancy tools in the world, but if you can't use them properly. Anyway, it sounds like these AIs are still learning. What were the developers' final thoughts after putting them through all this?
So, after all that, the space games, the Bitcoin simulations, what's the verdict? Are these GPT-o1 models the future?
Well, the developer made it clear we can't write them off just yet. Got to remember, this tech is still really young.
Yeah, it's like we're trying to teach a baby how to do, like, rocket science. Gonna take a minute.
Exactly. And every time we test these models, every success, every failure, it's a learning experience. He's definitely excited about the future, but for now, for things that need to just work reliably and quickly, he's sticking with Claude 3.5 and GPT-4. Makes sense. Sometimes you just need a tool that gets the job done, especially in the fast-paced world of software. But that doesn't mean we can't still be stoked about GPT-o1.
Right. Oh, totally. And that's what's so great about this developer's approach. He's not just running tests. He's asking the big questions like, what does it even mean for AI to reason? What can it do well? Where does it still struggle? And how will this change how we code in the future?
Big questions, for sure. And honestly, we only scratched the surface today. We focused on 2 coding challenges, but there's a whole universe of possibilities out there.
Exactly. And that's where you come in, dear listener. We've given you a taste of AI-powered coding. Now it's your turn to explore.
What other creative tests would you cook up to really push these reasoning models? What are they good at? Where could they use some work?
Maybe you're a game developer who wants to see if GPT-o1 can handle even more complex game mechanics. Or a financial analyst who wants to push its limits with even more advanced trading algorithms. Only limit is your imagination.
And there you have it, folks, our deep dive into OpenAI's fascinating new models. AI-powered coding is here, and the most exciting discoveries are still ahead.